Okay, so this is lesson 2 in our probability unit. We're talking about theoretical probability today. So that's what would happen in theory. Last lesson we talked about experimental probability. So theoretical probability is a probability based on the number of possible outcomes. It's not the results of an experiment, it's more about what we'd expect to happen. Okay, so let's look at an example here. It says a fair coin is flipped 10 times and it comes up heads 7 times. I'm just going to highlight those two numbers. The theoretical probability of getting heads is what we'd expect to happen. So how we calculate that is we just say the total number of things can happen, which is 2. It could be either heads or tails. And the chances we get heads is just 1 because there's one way to get a head. And there's 2 possible things that can happen. So in 10 flips, we'd expect 5 heads. But the experimental probability is different. It's what actually happened when you run an experiment. And again, that can fluctuate due to random chance, like we talked about last lesson. So here's what actually happened. Out of 10 flips, 7 came up heads. So those are a little bit different. And we talked about this key idea last time, which is the sample size. So that's how many trials we've actually run. So sample size impacts the accuracy. So the bigger the sample size, the more data that we have, the closer we expect the theoretical probability and the experimental probability to match. Okay, so there's less fluctuations due to random chance when we have more data. Okay, let's practice calculating some theoretical probabilities. We're going to use a standard deck of cards here. If you're not familiar, if you're not used to playing cards, I put some information about cards. So cards come in 4 suits, and there's 13 in each suit. So we have clubs that look like this, spades, hearts, and diamonds. Okay, so there's 52 cards in total, and then I have some of the information there. Okay, so we're going to calculate the experimental probabilities here. And we're going to write these numbers as fractions. Okay, so probability of drawing a heart. So there are 13 total hearts in the deck out of 52 cards in total. So that's how we calculate that. Or we could say that every 1 in 4 cards is a heart because there's 1 suit is hearts out of 4 suits total. So if we reduce this, that's what we'll see here. If we divide these by 13, we get 1 out of 4. So 1 out of every 4 cards is a heart. So your chances of pulling a heart is 1 out of 4. Chances of pulling a red card, so there's 52 cards total, and 26 cards are red. Half of them. Okay, so if we reduce that, divide by 26, we get 1 out of 2. Okay. Chances of pulling a black jack. So jacks are those J cards. I'm just going to highlight them here. So there are all the jacks. There's 4 of them in total, but only 2 of them are black. So there's 2 black jacks out of 52 cards in total, and we can reduce this by dividing by 2. So the chances that we pull a black jack out of a deck is going to be 1 out of 26. I'm just going to highlight my answers here. So when we calculate theoretical probability, it's how many ways it can happen out of the total possibilities. Let's keep going. A card other than a diamond, so not a diamond. So if we count up all the cards that are not diamonds, that's going to be 13 plus 13 plus 13. So 39 cards out of 52 in total. And if we divide this by 13, we can reduce it. We get 3 out of 4. That makes sense because 3 out of 4 suits are not diamonds. So the chances you don't pull a diamond is 3 out of 4. Okay, let's look at another way to calculate probabilities. One really nice way of writing down all the possible ways that something can happen is by making a table. So, and we like to make a table if we're doing something like rolling 2 die, and when there's lots of possible things that can happen. So when we roll 2 dice, this table shows us what happens on the first die. You can get 1 through 6, And then on the second die, you can get 1 through 6. So there's 36 things that can happen when you roll 2 dice. I'm just going to erase those because I'm going to use my highlighters here in a second. Okay, so this table shows all the different things that can happen, and we're going to calculate all of these. So these are all going to be, I can go ahead right away and put out of 36 because there's 36 possible things that can happen when we roll the 2 dice. Okay, let's do this first one. It says probability that both numbers are the same. So that's going to be all of these outcomes here. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So there's 6 different ways we can get both numbers being the same out of 36 possible things that can happen. So we want to reduce that. So that means 1 out of every 6 times you roll 2 dice. Sorry, I keep saying die or dice. You're going to get 2 the same on average. Okay. Add to 11. Let's do that one in orange. So 5 and 6 adds to 11, and so does 6 and 5. There's only 2 ways to get 11, a sum of 11. And when we reduce that by dividing by 2, we get 1 out of 18. So only 1 out of 18 rolls, you're going to have a sum of 11. Neither die is 6. Okay, let's highlight all of those. I'm going to do that in green. So that would be like all of these. That's a lot. It's almost easier to count the ways you can't do it. So we have a 5 by 5 grid here that I've colored in green. So that's 25 out of 36. And that doesn't reduce. So we can just leave that.